Leetcode 923, 3-sum with multiplicity. Count ordered triplets of indices with sum exactly equal to the target, where repeated values are allowed. The same multiset can contribute many triplets. Return that count. In the example, target 5 forces 1 plus 2 plus 2, 2 positions for the 1, times 6 ways to pick 2 2s from 4, so 12 triplets. Intuition. 3-sum with multiplicity, count index triples whose values sum to the target. Shared with Leetcode 15, 3-sum sort the array, fix an outer index, then sweep with 2 inward pointers, the same 2-pointer shell. The difference is the goal. Count how many valid index triples sum exactly to the target, not a list of unique value triplets. After sorting, the same value appears in one contiguous block. When the pair sum hits the target and both pointers show the same number, count ways to pick 2 different indices in that block. When the two ends show different numbers, multiply, copies on the left times copies on the right. Enumerating every triple is O, n superscript 3, too slow when n is large. Case 1, sorted array 1, 2, 2, 2, target 5. Fix I at index 0. The pair at j and k both read 2, and every cell from j through k is a 2, 3 cells, so pick any 2 different indices in that band for j and k. That is 3. Choose 2 equals 3 triplets for this hit. Look at the green band in the diagram above, 3 index slots, all showing 2. We need 2 different slots for j and k, with j to the left of k. Listing pairs gives 1 2, 1 3, 2 3, 3 pairs. That is 3. Choose 2, or m times m minus 1 over 2, 3 times 2 over 2 is 3. That is the only formula you need here. Next we move on. Case 2, sorted array 1, 2, 3, 3, target 6. Fix I at index 0. The pair sum at j and k is 2 plus 3 equals 5, which matches need. The left run of 2s has length 1, the right run of 3s has length 2. Multiply, 1 times 2 equals 2 triplets. Recipe: if both pointers sit on the same value, count pairs of indices inside that block. If they sit on different values, multiply the size of the left run by the size of the right run. That is the counting you need before approach. Approach: sort plus 2 pointers plus run counts. Phase 1, sort. Keep the array sorted so equal values sit in contiguous runs. When a match lands, you credit many triplets using those widths. Phase 2, fix I, then hunt pair sum equals need. Fix the first index, set need to target minus that entry, place 1 pointer just after it and 1 at the end, and drive the pair sum toward need. Too small, advance the left pointer. Too large, move the right pointer left. Phase 3, when pair hits need, count index triples, runs. Exact match and both pointers show the same value. The segment is one number. Add 1 triplet for every way to pick 2 different indices in that block, then end the inner loop. Exact match with 2 different values, multiply left run length by right run length, then skip both pointers past those runs. Repeat for every valid first index and add up all contributions. First example, j and k can land on the same value. We count those pairs with m. Choose 2. We sort the array so equal numbers sit together in one run. That is how we count pairs inside a band when the sum matches what we need. Fix I at 0, value 1. We need pairs of values summing to target minus that value, i.e. 4. Set j to 1, k to 3. Pair sum equals 4, triplet sum hits target. Unlike classic 3-sum, we do not move j and k once, we add every index pair allowed by the equal runs next. C, 3, 2, adds 3 triplets here, count 3. Inner 2-pointer pass ends for this I. Next I1, need 3 for the pair, count so far 3. Pair sum is 4, above 3, triplet sum is 6. Move k left to decrease the pair sum. Inner 2-pointer pass ends for this I. We sort the arrays so equal numbers sit together in one run. That is how we count pairs inside a band when the sum matches what we need. Fix I at 0, value 1. We need pairs of values summing to target minus that value, i.e. 5. Set j to 1, k to 3. Pair sum equals 5, triplet sum hits target. Unlike classic 3-sum, we do not move j and k once, we add every index pair allowed by the equal runs next. Two different values at the ends, each choice of index in the left run pairs with each index in the right run. Run length 1 times run length 2 gives 2 index triplets for this I. Then advance j and k past both runs, like skipping duplicates but crediting the full counts first. Inner 2-pointer pass ends for this I. Next I1, need 4 for the pair, count so far 2. Pair sum is 6, above 4, triplet sum is 8. Move k left to decrease the pair sum. Inner 2-pointer pass ends for this I. Example 1 ends with count 3. Example 2 ends with 2. Remember, the problem asks for the answer modulo 10 to the 9 plus 7. N is the length of ARR time is O of n squared after sorting plus the n log n sort. Extra space is constant aside from the output and the sorting stack. Pseudocode for 3-sum with multiplicity, sort, then one outer I with 2 pointers j and k. We walk each line next. Function 3-sum with multiplicity, input nums and target. Sort nums. Set the answer to 0. Set n to the length of nums. Outer loop, I from 0 to n minus 3. Set need to target minus nums at I. Set j to I plus 1. Set k to n minus 1. Inner loop while j is less than k. Set pair to nums j plus nums k. If pair is less than need, the sum is too small. Move j to the right. Else if pair is greater than need, the sum is too large. Move k to the left. Else the pair sum hits need. If nums j equals nums k, same value under both pointers. Set m to k minus j plus 1, the band length. Add m, choose 2 to the answer. Break out of the inner loop. Else the two ends show different values. Count the left run length from j. Count the right run length from k. Add left times right to the answer. Advance j and k past both runs. Return the answer modulo 10 to the 9 plus 7.